Alright, to find the arc length, you must first know what an arc is. A minor arc is 2 points on a circle, and it's the side of the circle, nowhere on the inside of the circle, on the side. So A, C, this whole line there would be the minor arc. A major arc would be when there's more than 2 dots. There would be 3 or even 4. For this one, there's only 3. A, D, C. Alright. Alright. The theorem for the minor arc is measure AC. AC is equal to ABC, the angle, and that is equal to the arc. So ABC is equal to 52 degrees. So then the minor arc AC is equal to 52 degrees. Now, for the major arc, which is ADC, we can do the minor arc thing to get the minor arc. You need to have the minor arc for this theorem to work. It is 360 minus x equals ADC. ADC. So, we have 20 degrees for our minor arc, because I didn't want to write another 20 down there. So we have 360 minus 20 equals 340 degrees, which equals measure ADC. Pretty simple. That's why I picked it. Alright. Now, to find the area of a sectors and segments, you first need to know what a sector is. A sector is 2 radii that are intercepting an arc, which these we'll pretend they are. Alright. Now, the theorem for this is that area is equal to pi r squared to the measure divided by 360. Pretty simple. Alright. For this one, we have 3 for the radii, so the radius is 3, and 20, it's out in the middle, but it's meant to be for the C. So it's the angle of ACB, which can also be the arc length because of the minor arc we just got done doing. Yay. Shadow thumbs up. Alright, so we put 3 in, and after the minor arc thing, got the measure, which is 20. The measure would be here. Not here. Here. Yeah. Alright. So 3 squared pi, because 3 squared pi divided by, or times 20 divided by 360. Wow, I'm doing good at this. 20, 360, which, and then you get A equals 9 pi times 20 divided by 360, which then once you add all those up and do fancy calculations, you get A equals 0.5 pi. Didn't see that coming. Right. To find the length segment of a segment formed by lines that intersect a circle, you need to know what the segments really are. Secant segment is the endpoints inside of a circle. Endpoint in circle. Very easy. The external secant segment is also very easy. It is anyone with an endpoint not in a circle. Endpoint not in circle. Alright, so we now know that. Now for the theorem. So for the secant segment, the one inside of the circle, it can be AE times EB equals CE times DE. That's an E. Yeah. Alright, so we have 6 for EB and X for AE. So we have 6X. And that is equal to 4 times 5, which is 20. Now you divide each side by 6, and you get X equals 4. 4. So if you wanted to, and you needed to find AB, you would just do 4 plus 6 and you get 10. Merry Christmas on that one. Alright, the external secant segment, a little bit difficulter, not by much. The theorem for this one is AC times BC. Oh, it's supposed to be B. BC is equal to another BC times EC. Alright, we're just going to pretend this one's D, because that's supposed to be D. D. Alright, so, with our imaginary D, we have X and a 4. Now for AC would be X plus 4. And then we would have BC, which would be 4, multiplied by that. And we would do the same for the other side. So I kind of broke this up so you can kind of see it. This would be AC, and this 6 plus 5 would be BC, real B, and RC. And then that would be just that measurement, and that right there would be our imaginary D and RC. Now we multiply all those together. So we got 4x plus 16, because we FOIL 4 times x, 4x, and 4 times 4 equals 16. Alright, then we've got 5 times 6. Alright, no, we can just do 6 plus 5 equals 11, and 11 times 5 equals 55, which I got there, but I crossed it out because I did this math ahead of time. Alright, so we got 4x plus 16 equals 55. Subtract 16, and then you get 4x equals 39 divided by 4, and you get a number. I didn't feel like calculating it, so just know that's how you get your number. Technically, I could just say it's x equals to 39 divided by 4, but Mr. Oliver wouldn't like that. Now for the bigger one. Write an equation and graph circles in the coordinate planes and solve problems. I probably didn't catch all that in the video. Oh well. For this one, you can use the distance formula, which is our common r for radius is equal to x2 minus x1 squared plus y2 minus y1 squared. Now, when you get the answer, put the coordinates in. This is not how you want it to look. You won't accept this. This is how you can find the radius if the problem doesn't give you the radius. You would put the two numbers in, the center point being here and here, and the other point being here and here, and then you would do math and get r. This is the way he wants you to look at, with this one having a number, that one having a number, and of course that one having a number. So, you would do, this one is another theory, r squared equals x minus h squared plus y minus k squared. Here's kind of an example. I really should have done better on the graph paper, but oh well. We have 2, 1.5, 1, and 0, and same. Alright, the center point is 1.5, because I'm writing this, so I made it so. Alright, and our radii is 2. Somehow that worked out for me. Alright, so the way you would write this, so that it's in the way he wants it to be written, would be to do 4, because it's r squared, and 2 squared equals 4. And then x minus 1.5, because on our x mark, 1.5, and that would go for h squared, plus y minus, look, 1.5, I'm a genius on this one, squared, and then that would be your answer. Or they may ask you to put in this form, where you make the circle and you make it 2 radii each way. Sometimes though, you don't have this, and you get the center point and like a point there. That's when you would use this to find out what the radius is. So then you can get this. And that's it.